Good evening, guys. This is Mike coming back at you with another video on college algebra. In this video, we are going to begin talking in general about matrices, some terminology associated with matrices, and some of the basic operations we can do with said matrices. So as we said in a previous video, a matrix is a rectangular array of numbers. Those numbers that are in our matrix, we call those guys the elements of the matrix. Typically when we write matrices, we give these things some name, and we commonly give them names that are capital letters, like A, B, C, D, whatever. The textbook likes to refer to them as such. In these square brackets, you have this A sub ij. And what they actually look like are things like this: A sub 1, 1, A sub 1, 2, A sub 1, 3, all the way over to A sub 1n, A sub 2, 1, A sub 2, 2, all the way over to A sub 2n. And then you go all the way down to A sub m1, A sub m2, and then over all the way till you hit A sub mn. And what do these A sub 1 1s and A sub 2 2s and all that, what is this A sub ij? It is the element or the number in the ith row and the jth column. So just as a bit of a warm-up here, just to get ourselves used to this notation of being able to identify particular elements of a matrix. Here I have this matrix. This is a 3 by 4 matrix. As we mentioned in previous videos, we often refer to a matrix by the number of rows and the number of columns. This has 3 rows and 1, 2, 3, 4 columns. So we say it's a 3 by 4. It's number of rows and then followed by number of columns. And this is also referred to as the order of the matrix. You're not going to hear me using that word super often. I'll say it every once in a while, but the textbook is going to refer to this as the order of the matrix. So that's just something to keep in mind, a word or phrase you could hear. So I'm just going to identify some particular elements in some particular row and column, and we should be able to figure out what those are. So for example, if I said A sub 2, 3, I want the element of this matrix here that's in the second row and the third column. So if I go second row, third column, the number that lies in both those guys is that 0. So that is A sub 2, 3. If I wanted A sub 1, 4, well, this is the element of our matrix that's in the first row and the fourth column. So what number lies in both those things? That 3 there. So that's going to be A sub 1, 4. On your own, try to figure out what A sub 3, 3 is going to be. Shouldn't take you very long. Should just take you a few seconds. So hopefully you checked third row, third column. Where did those intersect? At that 4. So that is what A sub 3, 3 is going to be. So you should be able to, given notation like this, you should be able to identify a particular element of a matrix. What does it mean for two matrices to be equal? Two matrices are equal if and only if they are the same order or the same size, and corresponding elements are equal as well. So the numbers in the first row and first column of each matrix are equal. So A sub 1, 1 for each of those are the same. A sub 1, 2 for those are the same, and so on and so forth. So the two matrices at the left here, if you saw 1, -1, 7, and -30, and then you saw x, -1, y, and -30, and you knew that these things were equal, and they wanted to know what the values of x and y were, then the only way these two matrices are equal is if these elements are the same, that is to say x is equal to 1, and if these elements are the same, that is to say y is equal to positive 7. So that's the only way that these two matrices would be equal. Corresponding elements of the matrices are equal. And again, the matrices have to be the same size. They have to have the same number of rows and the same number of columns. This right here is an example of two matrices that are not equal. This is a 2 by 2 matrix. This is a 2 by 3 matrix. Yes, the first two columns of these matrices are the same, but still, we have that extra column here. These are not equal matrices. We have a fairly special M by N matrix. It doesn't matter what or how many rows or columns it has, but the M by N matrix, who has all zeros as the entries, it's called the zero matrix, and we just denote it by 0. We're going to come to that very shortly and why we specifically mention that. So now onto some actual operations with matrices. Adding and subtracting matrices is very straightforward, very easy. We simply add or we subtract corresponding elements of the matrices. But again, just like when determining whether or not two matrices are equal, the matrices do have to have the same order or the same size in order to add or subtract them. They do need to have the same number of rows and the same number of columns. So here I've given you two matrices, A and B. Let's figure out what A plus B and what B minus A are going to be. So first of all, A plus B, 2, -3, 6, 1, 5, -1, and then -3, 0, 5, 4, 0, and -2. So I'm adding these matrices up, and as I said, I'm just adding or subtracting corresponding elements. So 2 plus the -3, because these are both the entries in the first row and first column. That's going to give me a -1. -3 plus the 0. Again, they're corresponding elements in their matrices. 6 plus the 5, 11. 1 plus the 4, 5 plus the 0, and then -1 plus the -2. And we get -1, -3, 11, 5, 5, and -3. As you saw, we just added or subtracted the corresponding elements. Guys in second row, first column, added those guys up. And similarly with the other ones. Now B minus A. -3, 0, 5, 4, 0, -2, minus 2, -3, 6, 1, 5, and -1. All right, so again, I'm just going to add or subtract corresponding elements here. -3 minus 2, -5. 4 minus 1, 3. 0 minus the -3 is a +3. 0 minus the 5, -5. 5 minus the 6, -1. -2 minus -1, 2 plus, -2 plus 1, which is a -1. So very simple, very straightforward. I don't think we need to go through too many more sample problems here. If any, I think it's very straightforward. Much like just numbers, every matrix A has an additive inverse. There is some other matrix out there such that if we add these two, we get the 0 matrix. So the m by n matrix A, which is, again, this A sub ij, has an additive inverse matrix. It's m by n, and we write it as -A. But what it really is that it's just the negative of the corresponding elements in the given matrix capital A. And when you add these two matrices, no matter which way you add them, you get your 0 matrix. And then just to wrap up this video, some other properties of adding matrices. These should look very familiar. It's the exact same thing as working with just individual numbers. The order in which we add matrices does not change what we get. If we're taking the sum of 3 separate matrices, whatever 2 matrices we add first, it doesn't matter. We're still going to get to the same results in the end. And the third one here, if you take any matrix and you add the 0 matrix onto it, you're still going to get the same matrix that you had to start with. So guys, this was the first of 2 videos on the sort of basic operations we can do with matrices, adding, subtracting, and then just a little bit of intro and terminology into some matrices and things associated with them and what they are. In the next video, we are going to talk about scalar multiplication of matrices, as well as multiplying 2 matrices themselves, which is an interesting little calculation. If you have any questions or comments, please be sure to reach out to me, guys. Emails, flare signals, SOS bonfires on deserted islands in the middle of the ocean. Whatever you have to do. Until the next video, take it easy, guys.